Hi guys, in this video I will show you guys how to solve inequality. So keep in mind, inequality is different than equation, is that inequality has more than one solution, and usually the solution will be written as interval form, or you can use inequality form. So let's use our prior knowledge to solve this problem, and we solve this problem algebraically. So then first I will try to get rid of x plus 3 on both sides because I don't want to deal with fraction. So that means I multiply by x plus 3 on both sides. Okay, and that allow me to cross this off, and on the right side I will use distributive property. So now on the left side I have x squared minus 8x plus 3 greater than 6x plus 18, and I bring everything to the left side now. So I will have x squared minus 8x plus 3 minus 6x minus 18 greater than 0. And I just try to combine like terms. So I have x squared minus 14x minus 15 greater than 0. And at this step, I will treat it like an equation. Okay. So then I would have x squared minus 14x minus 15 equals 0 to make it easier for myself. And I noticed that this quadratic function is factorable. So on the side I'll do factoring. So then factoring means I take the last number as negative 15 and the middle number is negative 14. So now I have to look for the two numbers that multiply to get the top number, which is negative 15, and adding up to get the bottom number, which is negative 14. Okay, and the easiest way to do it is I try to list all the factors of the top number. So I have negative 15, usually just take 15, and then I have 1, 15, 3, and 5. I think that's it. I believe that's it. And then now think about which pair, when you add them up, is possible to give you negative 14. Pretty much the first pair. So now I need to consider, I need to get negative 14 when I add them up. So therefore, I put the negative sign on number 15. So now put them back. I have positive 1 and negative 15. Double check it last time before I actually use it. So I have 1 times negative 15. That give me, so 1 times negative 15. That give me negative 15 on top. And I have 1 plus negative 15. And that give me negative 14. Okay, awesome. So now I have x plus 1 and then x minus 15 equals 0. Okay, so now that means I have x equals negative 1 and x equals 15 as the solutions. So I will try to use number line to sketch my solution because I'm a visual learner, so it's easier for me to put them on the number line. So on number line I have negative 1, I have 15. All right. So I would treat these 2 points as my critical points. And because we have strictly greater than, so therefore this critical point will be open dot. So I have open dot at negative 1, open dot at 15. And one more value that's not from the solution, but we need to pay attention to, which is x plus 3. Because x plus 3 is the denominator of the left side. Therefore, it will become an asymptote when you graph it. So therefore, we have x plus 3. We set it up equal to 0. And then we have x equals 3. And this will be the way how we find asymptote. The asymptote. Okay. So then, sorry, minus 3. I messed it up. So then on number line, I also add one more critical value, which is negative 3. And at negative 3 will be also open dot because it's the asymptote. So therefore, I don't have any y value that can have x equal negative 3. So now on the number line, I have 3 critical values. I have negative 3, negative 1, and 15. And now I will try to divide these into 3 different regions. And I will pick the value between each interval here, and I will plug it back into the inequality to make sure it works or not. So for the first region or the first interval, second I label them, or first during the first interval, I take one value. I will pick negative 4. Okay, so then for negative 4, take this right here. So when x equals negative 4, I will have negative 4 square, and very be careful with negative sign. And when you put it back in, make sure you have, because it's negative number, make sure you have parentheses, wrap them around. Equals 8 times negative 4, that's should be inside the parentheses again, plus 3, everything over negative 4 plus 3 and greater than 6. I put a question mark here because we don't know it's greater than 6 or not. Okay, and do the calculation. So then if we do the calculation, we have this will give you 16 plus 32 plus 3 and everything over 1 greater than 6. It seems like it doesn't work out because on top we have we will end up with a positive number and it's divided by negative number on the bottom, so that would turn into a negative value, and a negative value cannot be greater than 6, so this region doesn't work. Okay, so we cross it off. It doesn't work. Right now I will pick a value between the interval negative 3 and negative 1, or I will pick a value in second region. Okay, either way you call it. So I'll pick negative 2. So I will try it out and test it out. So I have x equals negative 2. So then now I try to make it organized. So now I have negative 2 square times negative 8, and then times negative 2 plus 3, and then negative 2 plus 3, and greater than 6 with question mark. So now I have 4 plus 32 plus 3, everything over 1. And yes, it's greater than 6. So yes, this one worked out. And so on. So the next value, I pick 0. So for the interval between, and sorry, I missed out one more region right here. It should be region number 4 right here after the 15. So for region number 3, or for the interval between negative 1 and 15, I'll pick 0. Okay, so I try it out. X equals 0. So now I have 0 square minus 8, times 0 plus 3 and have 0 plus 3 greater than 6 with question mark. So it gives me 0, 0 and 3 over 3 equals to 1, and it cannot greater than 6. It's false. So therefore this region doesn't work out. And we can try with the last region. So then I pick number 16. So now I have x equals 16, and I have 16 squared minus 8 times 16 plus 3 over 16 plus 3. And so we already did all of them. The last one you should be able to do it, and the result will be the last one workout. So now we know that the interval between, so I extend this one, the interval between -3 and -1 works for this inequality. So that will be the solution. And also the interval that after 15 will be solution. So now you have to state the solution using, you can use either interval or inequalities to state your solution. So I will use interval, and I also show you how to use inequalities. So for this, I will move this up a little bit up here, so I have space to write my final answer. Alright, so for my final answer, I will have use an interval first. So using interval, I will have -3, -1, and because both of them open dots at both ends, therefore I use parentheses. And then we have a gap between them before we get to the next solution, therefore I use union notation. And then I have 15 go all the way to the right, to the end right of the number line, so therefore it will be positive infinity. So we have 15 and all the way to positive infinity, and also at 15 we have open dots, so therefore it will be parentheses. For the infinities, we always use parentheses. Alright, and then that's the solution if you use interval notation. And now I'll show you how to use an inequality notation. So then if you use an inequality, you have -3 less than, so it has to be strictly less than x, strictly less than 1, or, so union will be or, and then you have x is greater than 15. Or you can do the other way, which is 15 less than x. So if you do this way, you will keep the order as least to greatest all the time. Okay. For interval, you have to keep the order as least to greatest. Is a have to, is a must. For inequality, you can switch a little bit by using the inequality notation by switch it to greater than. But if you do greater than, you have this. You have -1 is greater than x is greater than -3, or x greater than 15. Okay, but I try to keep it easier, so I just need to remember that least to greatest means left to right, in order of left to right on the number line. Alright, hopefully this video helped you guys understand a little bit more on how to solve inequality.